Hello everyone, welcome to Module 6 on chemical reactions. The first thing I'm going to say here is this is an extra long module. In fact, we will be spending 2 weeks on this module. So it looks like there's a lot of stuff there, and there is a lot of stuff there, but we will be taking our time to go through it. There is a point I would like you to get to the first week. But if you would like to proceed on beyond that, you may do so. Particularly that might be useful because the first exam is coming up soon, and that might give you additional time to prepare for that exam. So let's go ahead and jump into 6.1. Okay, so 6.1 is an introduction to chemical reactions. So these are the types of things you should be able to do by the time you're done with this module. Identify evidence of a chemical reaction. Interpret the common symbols used in the chemical equation, including symbols for the physical states of substances involved in the reaction. Classify a chemical reaction as synthesis, decomposition, single displacement, or double displacement. Okay, so I want to first of all talk about what we mean when we say we have a chemical reaction. A chemical reaction is a transformation of elements or compounds into new arrangements of those elements. So we're showing an example here of an internal combustion engine where you have some molecules of the gasoline, and you have oxygen. And this is showing, this is a representation of how these elements are connected in their in these molecules before they go into the engine, and then here we're showing this is how they exist when they come out. So that's the change. We have rearranged the ways in which the atoms that make up these substances are connected. So when we have a chemical reaction, that's essentially what's happening. Well, how do we know when it happens? There are some things we can observe to indicate that are indications of a reaction. So I want to talk about a couple of examples. So if you have a solid form where there was not a solid before, so example, you mix two liquids together and you see a solid, that's evidence of a chemical reaction. If a gas forms, so here we're showing a solid placed in water and it's forming a gas. So that's evidence of the chemical reaction as well. Notice when we talk about these phase change, these solid and gas formations, these are not phase changes. We're not changing from solid to gas because we're heating it in a sublimation, for example. We have a new substance forming with a new physical state. So just be aware of that. If something is emitting heat, that is a result of a reaction, or absorbing heat. So either emitting or absorbing heat is evidence of a reaction. Emitting light, so if something is glowing, that's evidence of a reaction, or a color change. All of these are evidence of chemical reactions. Now there are some chemical reactions that we will not be able to detect the changes that happen. So you might not always see something when the reaction takes place. But these are things, when you do see them, you can be pretty sure that a reaction has occurred. We keep track of reactions with a chemical equation. And here we're showing an example of a chemical equation. And what we're showing here is we're showing the change that occurs as time goes by. So we start out with reactants on the left side, and then we end up with products on the right side. And we have an arrow here. And this arrow, think of this arrow as the flow of time. So you have these things, and as time goes by, you no longer have those things, you have these things instead. And we're really looking just at, we start here and we end here, and we're not worried right now about what happens in the middle of that. So we start with these things, we end with these things. So we have some arrangement of atoms over here, a different arrangement of atoms over here. So the arrow is indicating the direction in which it's occurring. The plus sign is to distinguish between different substances. So we have this substance and we have this substance. We have this substance and we have this substance. It doesn't matter the order of the substances. So we could have written this O2 plus CH4 or H2O plus CO2. So the order doesn't matter. The order within the substance does matter. So we would not, for example, write this as O2C. It is CO2. So the order within the substance matters. The order of the substances does not matter. And then we also have these numbers. These numbers are what we call coefficients, and these numbers are indicating how many, basically at this point we can think of these as molecules, how many molecules of oxygen we have here. So we're saying 2, so we're representing this pictorially as well. We don't have a number here. If we don't have a number, we assume that is a 1. So we have 1 of this and 2 of these. And over here we have 1 of this and we have 2 of these. Okay, so reactants and products, reactants change to form products. So a new arrangement of the things that are present there. A few other things that are going on here I want to talk about. So you'll notice that there is this G in parentheses after everything. We will sometimes in a chemical reaction include some information about the physical state of the things taking place in that reaction. So the G is to represent that we have a gas phase. We also sometimes have an L for liquid. We could have an S for solid. So physical states you're probably all familiar with at this point. There's a fourth one I want to talk about, and this is called aqueous. So aqueous means dissolved in water. This is something we'll get into in more detail in a later chapter. Actually, your chapter 7 does talk about this, but we're going to delay that until later. For now, understand that it means that something is dissolved in water. And the exact process for that we'll get into later. Just understand that this is true for a lot of things. You will see many reactions with the AQ for aqueous. I want to talk about classifying chemical reactions. So we can look at chemical reactions and see similar trends occurring and maybe put them into some categories. So I want to talk really briefly about this set of categories, and there's another set we'll talk about as well. A precipitation reaction is a reaction in which we have two liquids combined to form a solid. We saw a picture of what that could look like earlier. That solid we call a precipitate, so these are what we call precipitation reactions. An acid-base reaction, you have an acid reacting with a base, and there's a neutralization. We'll look at this reaction in more detail in a later chapter. We have a gas evolution reaction, so this is a reaction where a gas forms. It turns out a lot of these are because you have an acid. Okay, so that is something, again, we'll see in a later chapter. Oxidation reduction reactions we'll talk about in a later chapter as well. This involves the transfer of electrons, as we'll see. Any type of combustion is a type of oxidation reduction, as it turns out. Okay, so some of these, again, we'll get into in more detail in a later chapter. For now, I want to look at another way of classifying reactions. So we can look at a reaction and classify it in terms of how the things that make up the reactants and products are rearranged. So there's 4 possibilities here. The first is what we call the synthesis reaction. In a synthesis, sometimes called the combination reaction, we have two things that are separate that are then joined together into one thing. So here we're showing A plus B forming AB. They come together to form one thing. A decomposition reaction is essentially the opposite of a synthesis reaction. Here we have something that you have things together that as they react they separate, they break apart. So that's a decomposition. In a single replacement, sometimes here we're calling it a single displacement reaction. What happens here is you have two things that are together and another thing by itself, and that thing basically takes the place of something in this compound. So we have A plus BC reacting to form AC plus B. One thing about the order here, whichever thing is staying as part of the compound, so the C in this case is paired up with B and then paired up with A. it is always in the same position. So here we're showing it in the back. That is often going to be the case. It will be the thing in the back. There are some cases where the thing in the front stays the same, but the idea is whichever one is paired up stays in the same position relative to where it was initially. And then finally we have the double displacement reactions. In a double displacement you have one combination and another combination, and they basically are switching places. It's like they're switching partners. So AB and CD to start with, and we end up with AD plus CB. Now when we do this, again, the order does matter within the compound as it did up here. So A is in the front, A stays in the front, C is in the front, C stays in the front. B is in the back, it stays in the back, D is in the back, and it also stays in the back. Okay, so for double displacement, the order within those compounds does matter, and it might be a little bit tricky because everything there is changing places. This is a type of reaction your book goes into a lot of detail on. We'll look at that a little bit, but again, that's something we'll push off most of it until a later chapter, or until, I should say, a later module. Okay, that is it for section 6.1. So go ahead and complete worksheet 6.1. If you have questions on anything in that worksheet, ask them in the discussion board, and then proceed on to 6.2 when you are ready.